Hello students. So today I'm going to talk about the area of a square, area of a circle application that we worked on yesterday. And it's going to be, I think, somewhat of a lengthy video because I need to go over the classes and the lists and some of the different things that we did in this application. I'm starting with where we left off before. So you'll recall our little application here. If I run this thing, we have our little form. It pops up and we can say 3, submit. We get the area of 9. It assumes it's a square because circle's not checked. If I click on circle, then it becomes the area of a circle. Really easy. This is the application that we did before. There's a video on this application specifically, so I'm not going to rewrite the code for this app because it's already been done. Let's go ahead and take a look at the code. So if you recall, this is the code. We have a calculate area of a circle, the function, which I went over, like I said, in a previous video, so I'm not going to do it again. Calculate area of a square, and then our subroutine, let's clean that up, get data, which has our variables and our decision point, see if it's checked, and look for the area of a circle. Output to text box 2, of course our event handlers, our submit button event handler and our close button event handler. And like I said, there's a video that goes over how to get to this point, so I'm going to assume that you can watch that and figure this part out, and then let's go onwards with the assignment. The first thing I'm going to do is I'm going to go over to the Solution Explorer. I'm going to right click on the project and I'm going to click Add. And I'm going to click New Item. We're going to select Class, and we're going to rename this class to something that makes sense. Don't leave it as just named class, because that doesn't make any sense. And we're going to call this one the Input. Sorry, tired already. Input Validation Class is what we're going to name this one. And it's self-explanatory. We want to create a class that's going to do nothing but input the validate the input, whatever these are inputs. This part could easily be done in the class form 1, but I'm doing this because if we were writing a more complex application, you would create a separate class to do all the validation code. And so I want you to get used to keeping your validation code in a separate class, and that's the purpose for this. Okay, so the keywords you want to use is public and shared. This ensures, public and shared ensures that this class, it will be accessible from the other classes. Without this, you will not be able to access your class. Okay, so I'm going to name this one name check, and I'm just giving it the name arg. It's just a variable. We could name it anything we want. Typically in programming, people will name this arg because it stands for argument, and when you create a function, you're passing it an argument, and so a lot of programmers will just name it arg for argument. If you have several arguments, a lot of times programmers will name argument 1, argument 2, argument 3, but in this example I'm just going to name this one argument, arg for argument, and then we're going to declare it as a string. Okay, I need a test, and we're going to use Boolean. Going to set test to false, assign it to false. I need a decision point. And here we're going to say case. We're going to pass it arg. We have 2 case situations, and this one's going to be case false. This one's going to be case true. And select Clean this up a bit. And if we're in a function, we have to return something. So let's return test. And function. So let's go ahead and rework this just because, as I look at this, it really kind of doesn't make any sense. So I'm going to go ahead and delete this and all this to here. Okay. So what I did here is I created a class called a public shared function numcheck. We're going to pass it an argument as a string. The argument's going to be returned as isNumeric. IsNumeric is a reserved keyword or a reserved function in Visual Basic that, as you can see, returns a Boolean value indicating whether the expression can be evaluated as a number. So here's the thing. This part is so small, this could and normally would actually be done in the main Form 1 VB. I'm only setting it up this way to help demonstrate the fact that if we were doing validation input, we would have our own class of validations, and there would be a whole bunch of different functions here that we would use to check our validations. Probably using something with regular expressions, which I really want to teach you guys in a different video. But for right now, just know that I'm only doing this to demonstrate that we would be having our validations in a separate class. That's all I'm doing. Yes, this right here, this piece could be done inside the Form 1. All right? So that's all that's about. So what's going to happen here? We pass an argument to this function that we created, and it's going to go to the reserved function that's installed in Visual Basic called isNumeric. And this is going to return a true or false depending on whether it's a string or not. And that's it. That's all that happens there. Okay. Okay, so we're now going to go to the Form 1 VB, the original code here. And we need to put in our we need to access our input validation code now. So let's go ahead and do that. And where we want to do that is in the get area subroutine, which is going to be a separate subroutine. So let's go ahead and do that. We need to create a new subroutine. And we're creating a new subroutine because we now have to create a decision point that's going to test for the valid input. And so that's the purpose for that. Okay, so what I did here is I declared a variable called test. I set it as a Boolean because it's going to either be true or false. And I'm going to set test equal to whatever the input validation is. So for example, in our text box, let's go back to our design, we have our text box. We're going to give that a variable, and we're going to say, okay, get whatever's in that text box, let's pass it to the input validation class that we just had here, and then from here into the function numcheck, and let's see if it's numeric or not. So that's what's happening there. Now, depending on how it comes back, we're going to see what we want to do. I'm going to use a select case statement You could do this as an if-else statement. In our case, we're going to start with true. And I'll explain all this in a moment. All right, so what I did here, we created the subroutine get area. We're going to pass, we have our new variables. We pass it to the input validation.numchuck function to test it to see if it's actually a number. And then we have the select case test. So we're going to test it. We're going to see what it came back as, true or false. If it's true, we're going to go ahead and get the data, which is going to pass it to our main function that decides whether it's a circle or a square, and the main subroutine. And then if it's not, then we're going to say it's an invalid entry. Okay, so right now this isn't applied yet. I don't think we get data. Yeah, so that's not applied yet. So let's see what happens if we run right now. So the whole purpose of this is if this is a bad entry and it fails, which is as expected because we haven't applied it yet. All right. So that's why we wrote this little get area piece, because we want to know if it's a valid number or not. All right. So now let's apply this. And the way we're going to do that is down here in our subroutine, we need to switch this from get data to get area, so that it's going to call the subroutine that we just created. And then if this is good, then it'll go to the get data subroutine. All right, let's run that. And I haven't tested this yet, so we'll see if it works. Yep, okay, so it's a bad entry. We get our little comment, invalid entry. All right, let's put in a number. There it is. And let's say it was a circle. Perfect. All right, and let's say that there's a typo and there's a T at the end of invalid entry. So now this is working. We're checking our validation, and we're not allowing an invalid entry to happen without taking care of it. So we want to be able to do that on any of our entries. So that is the first part of the assignment, and that was to check the validation. We created our input validation class. We used the isNumeric built-in function of Visual Basic. And again, this could have been done in the Form 1B. I'm only doing this because we would normally have other input validation checks that would go in this class. All right, and then we have our little our decision point. Did it come back true? Did it come back false? If it came back true, then let's get rolling with the next procedure. If it came back false, then send out an invalid entry. You could do a message pop-up box here if you wanted to, but to keep it clean, I just send it back to the text box. Okay, so the next thing we're going to do is we're going to now organize things a little bit more, a little bit better. We're going to create another class, and we're going to do another function, because what we want to do now is I want to take this form and I want to collect the information that the user inputs. So right now, every time a user submits information and runs the calculation, it's done. If they do another one, an additional calculation, the information's lost. Now we want to collect that information. So I want to emphasize there's various ways that you could do this. You could collect this information using an array, a stack, a database. There's so many different ways you could do this. We're going to do it in a list, and since that's the most common way that it would be done. All right. First thing we need to do is we need to create the list we need to create the list class. So go back to add, we're going to another new item, class again, and from here, now I just named mine lists. You could name this anything, and the reason I named it list plural is because in a lot of applications you're going to have more than one list. You probably will have several, and so I like to keep them nice and organized in a list class. In this application we're going to have just one list, and that's good. We keep things simple. Alright, so first thing again, public shared, because we need to be able to access the this thing from we're going to be able to access this from other classes. And we're gonna create this part way because we're gonna have other things we need to do. So the first thing we need to do is actually create we need to actually create our class for the inputs. So let's do that first, which is what I should have done first. Because this is the part that actually creates the properties of the list that we're going to be using. So that's why we needed to have done this part first, but we'll write it right now. I'll go over all this in a moment. Okay, so let's clean this up. So what we did here is we created the public class inputs. I, again, could have named this anything. I just named it inputs. And this is going to set up the constructor for the class. It's going to tell us what the properties are for each for the list. And we want 3 properties because we're going to be collecting 3 things. We're going to be collecting the user input. So X, whatever they entered. Y is going to be the area. I could have named it A. Probably should have named it A. And S is going to be the string, whether the shape is either a circle or a square, because I want to collect this data. And I want to be able to do this as the user inputs their information. So to do that, I need to set up the properties of what's going to be. So that was the first thing that we needed to create. Now we can create the function that's going to actually build this list. So in the function, we know that we need to keep track of the index of where what the user's actually inputting. There's a million ways this could be done. This is just the way I did it. So just know that this is not the only way this could be done. And I'll explain all this here in a minute. Okay, so what I did is I created a function, well, and every function has to return something, so we might as well throw that in. So what I did here is I created the public shared function, so this can be accessed from other classes, called inlist. Inlist is going to have these arguments. I, as an int16, this is where I'm going to keep track of what element in the array we're at, or I'm sorry, what element in the list we're at. And so that's what this is for. X is going to be the user input, whatever the user input. A is going to be the area that was calculated. S is going to be, was it a square or was it a circle? And indata is going to be the list itself. So I want to accept an entire list. In this function, I'm passing it all this information, including a list. Yes, you can pass a list. And I'm telling it what kind of list I'm passing. I'm not just passing it any list. I'm passing a list of the type of this class inputs. So it's going to have these properties. You have to do that so that the function understands that list is going to have properties. It's not just going to have one item. Okay? So now that we've done that, let's write some more code. So this right here says, okay, I'm taking the in-data list. I'm going to add to this list. So whatever was passed, the list called in-data of type inputs that's passed in this function, I'm taking that same list and I'm going to add to it. And what am I going to add to it? Well, I'm going to add to it the information that I passed to the function. So we have to say items, or item, sorry. And I want to tell it what index I'm putting this information. I got to tell it the property, and I'm going to set it equal to the information that I just sent it. So let's just do one of these for right now. So from the list in data of the type inputs of this class that I passed to the function, I'm taking that same list and I'm going to add to the list the new inputs. So this stuff here. And what am I going to do to it? I'm going to add to it to item I. So whatever the index, wherever I'm at, to that index. So the first one would be 0. So I'm going to add to index 0. And I'm going to add to the property x, which is defined here. I'm going to pass it whatever was passed over here. So when the user entered, let's say the number 4, I'm going to pass the number 4 here. This is the number 4 here. So in data, the list in data that was passed at the item I being the index 0 dot x property x is going to be assigned the value of 4 if that was what I passed. Okay? Now let's do the next one. We're still on index 0. This time property y, and y is going to be assigned whatever y is that I passed it up here, except for in this case y is not y, which is, like I said, to stay consistent, I should have named it y, but that's all right. I named it a. Okay, let's do the next one. Still in element 0. And now s. Okay, and we're done. So public shared function in lists is going to be passed to these variables: I for the index, x for the user input, a for the area that was calculated, s for whether it was a square or a circle, and then the list itself that's going to have information already. And the first time that won't have any information will be index 0, and then we're going to in that list, the same list that we passed it, we're going to pass it into index 0 straight across, property x, the value of x, property y, the value of a, in this case, whatever we pass as a decimal, property s, the value of s, so whatever information the user put. So now our class, our public shared function is created, our class is created, and we're ready to use this. So let's go back to the form now. So we're back at the form, and at the very top, at the application level scope, I'm going to go ahead and put a couple of application scope variables, and I'll explain why here in a minute. I kind of messed this up, so let's fix this. All right, so let's explain what happened here. So what I need here is I need to declare an integer, which I called n, and that's just for keeping track of the elements of the list that we're going to be passing, because I have to know where we're at. Now, the reason I had to make it an application scope variable versus a function or subroutine scope variable is because whenever I click this subroutine for the button to calculate area, I need to keep track of where we're at, the index 0, 1, 2, 3, etc. as they push this button. If I put it in scope inside of the function scope, what would happen is I would lose track of, is it a 0, is it a 1, like where are we at every time we click this button. So the easiest thing to do is to just throw it as an application scope variable. You don't want to do this very often, in fact very rarely, if at all. It's bad practice to do it with too many things. The other thing I'm going to do is I'm going to go ahead and declare my list. So I have my in data list, and this is the code for saying I'm going to create a list of types of list. So we're going to say we're declaring in data as a list, but not just any list. We want the list of this type. Meaning going back to our list class, it's going to be of this type here, of lists inputs. In other words, it's going to have these properties. So when we go back here, we're saying we're going to have the list in data as a list, but not just any normal list, a list of the type from lists.input. So it has the properties that we need. And it's going to be a new list of that type. And so that's what this is all about. We're declaring this variable in data. And it's lists of lists. Okay? So we're at that point now. And we're going to want to go to the get area subroutine here. And we're going to have some more things to do here. And so let's go ahead and do that. Actually, let's go check that get data. So once the decision point has called the get data, so we're actually ready to do work. So it passed validation, and now we're ready to actually do to calculate the area because the user input was good. Now this is where we're going to do some more work. So because here we have all our variables, we know what everything is. We know the variables, what the user input. We know that A is the calculated area, whether it was a circle or a square. I mean, it's right here, textbox2.text equal A. So we have all the calculations done. Now all we have to do is we need to populate our list with the information that the user input. So that's what we're going to do. Very simple. Watch this. Populate list with data, our little comment. We're going to take the list in data that we created above on application scope, and we're going to this time what we need to do is we're going to call the class list, but this time we're going to call the function that we created in lists, and we got to pass it the variables. N is going to be above whatever. Remember, we set that up there. Let me type this in and then we'll explain. Okay, so here's what's happening. In data, which we created at application scope right here, this list, we're going to pass that list. We're going to pass that list the lists. So from the class list and in lists. So the function, which was this right here, we're going to pass that. We're going to pass that the variables, the data that we need, and the data is all here. So n is going to be this one right here, which we start at 0. N is going to be 0, and then var is right here. It's text box 1 is whatever the user input, and then A is the calculated area regardless of whether it was a circle or a square. S is whether it was a circle or a square, and then in data the list itself. So we're going to pass it the list, so that way the list is always updated. That's what we're doing there. Okay, so we're just missing one more thing, and that's this. And what this does is this, after we've called the function in list and passed it these variables, we need to set the element of the list. We need to prepare it for the next entry.
the next entry would be element 1. So we're going to increment from 0 to 1, and that's what this does. It's going to increment the next element. All right. So at this point, we've got a lot of cool things going on, but we don't have any output. So we need to create some output because we want our information. Oh, you know what else? Is we need to create a new text box. We don't have a place to put our output. So let's do that. Go back to our toolbox, command controls. Let's pin it for right now. Text box. We need to go to properties, and we need multi-line. I usually do the horizontal scroll bar too, and that's here, or vertical, I'm sorry. And we also want it read only not to be true. So let's, here it is, read only false. Now we need read only to be true. So that way people can't enter data into it. It's not for data entries, for just for information coming back. Okay, this is looking good. All right, let's save that. Let's go back to our code. And now we're ready to do output our list. And we're just going to use a simple for loop. And that's the this is the syntax for a for loop in Visual Basic. STOut was created up here. This is the STOut dim STOut as string, and STOut is, we set it to nothing, to an empty string, and then we're going to use it right here for our output. Oh, I don't want to okay, so let me fix this. Okay, input in data item I. To string. We're going to use the ampersand to concatenate. Space it so it looks nice. And a lot of times what I'll do is I'll just copy and paste. Of course, I have to insert, so. I'll explain all this in a minute. Okay, so STOut, the string STOut, is going to equal to the input. I just naming it that so it comes out that way. And it's going to concatenate with in data, what was in the list, item I, so where we're at in the index. And it's going to it's going to parse it as a string, and then it's going to say, okay, what about the area? The area is whatever's in index I element, that property Y, and then and then the list item wherever we're at in the element, and then property S to string. And that's it, almost it. Looks like we're missing one line of code here. Because for it to look nice, we need to do one more thing for readability. And that's we need to say, in Visual Basic, the keyword here is new line, and it does exactly what it sounds like. So the string is going to output this information, and then it'll create a new line, and that's what happens there. So this right here is what was added for us to actually capture the data that the user input and submit it to the string, increment or submit it to the list, increment the list, and then output the list. So, all right, so let's see what happens. I haven't tested this yet, so first of all, let's check our validation code. Nothing should happen here. Cool. All right, let's put in 4, submit, and it didn't work. So now we have to troubleshoot. Cool. And as I look at the code that we wrote, it's clear what happened. Everything's working. And remember, code does exactly what you tell it to do. And so what I forgot to do is I forgot to tell this stuff where to go. It's going nowhere. So let's tell it where to go. Textbox3.text is going to equal st_out. Now it has a place to go. Now let's try that again. So again, our validation works. Let's try 4 again. Voila. Oh, that's not pretty. Let's try the circle. Cool. And the idea, though, is that we can collect multiple entries. So let's try 5. So that's working, except for it's not pretty. So let's fix that. And that's just a formatting thing. And we can put it right here. That ought to do it. All right, let's see. Yep. So as you can see, we're collecting our information, we're storing it, and we're outputting it, and we have it. We can do more with it now if we wanted to. So the list is ever growing as we enter data, and we're displaying it. The list isn't going away. It's not just being displayed here and forgotten. We still have it. It's still stored in our list. So right here, when we populate this list with this, when we call the function list.inList, and we pass it these variables, it's just being stored in our list. And we can, right here, we use a for loop to output the list, but it's still in the list. We can, if we were doing other calculations, we could pull the data out and we could run calculations with them over and over again or do other things with them because they're still stored inside of our list. All right, so that concludes this lecture. I hope it was informative, and happy coding.